Hi, this video we're going to be talking about what is thermodynamics and why do we have to study it as engineering students, right? So thermodynamics, let's decode this name. Thermo means heat, dynamics means moving, right? So thermodynamics means the movement of the heat, right? The movement of the heat. Heat is actually energy. So now let's think about what applications do we have the movement of the heat? If you think a little bit deeper, you realize pretty much a lot of things. Uh, Here's just for example, right here, application. So you have a solar cell panel that's related to the heat, and that's providing the heat from the sun and getting to the water heater tank, and there's a heat exchanger. That's thermodynamics application. And the same thing for refrigeration. And later on in this course, you're going to learn about refrigeration cycle. And that's part of thermo. And then how about in aircraft? That's true. And then HVAC, it's similar to the refrigeration, and that's another thermodynamics. Um, in our human body, we take the food, and that calorie intake is converted to, do all the body functions. So there is conservation of the energy, heat. So that's thermodynamics too. And all those energy released environmental issues through those refinery. That's also thermodynamics. So if you look around, thermodynamics is like everywhere. This movement of the heat. And then what will we learn in thermodynamics? You know, uh, so we're gonna learn a few laws of it, and this is just a quick display and very quick rundown. So we're going to talk about a few laws. The first law is define the temperature. It's called common sense law. And basically put hot and cold together, they're going to reach out that thermal equilibrium, reach out the same temperature. That's Zero's law. Okay. And the first law is define the energy. That's basically conservation of energy. So energy cannot gain or loss, and it's all conserved. And the second law is define entropy. And this is a very abstract. And later on, we're going to learn a few statements to define this entropy. But one simple thing is basically second law determine the concept of going one particular way. For example, if you have a hot coffee in your hand, and the heat is going to be transferred from the coffee to your hand, and so the heat is transferred from hot to cold. That's defined that particular direction is going, and it will not going from cold to hot. For example, we're not going from the heat will not transfer from your cold hands back to the hot coffee, right? Later on, for example, you will not be able to cook steak in the fridge, right? So that's telling you the second law of entropy. The third law is basically telling you we can never get into 0 Kelvin degree. 0 Kelvin degree, so that's absolute zero. That's like a negative 273 degrees Celsius. So here it could tell you from upbeat to a little depressing. That's how I learned about thermodynamics laws. And so thermal is really used a lot. Just thinking about, like, if you get a chance to visit a power plant in your city, you will realize that's thermodynamics a lot there. Whether they are using natural gas or coal to heat up those water, and create a very superheated vapor, and then convert that thermal energy to mechanical shaft or turning inside the turbine, and then change that mechanical energy to electrical energy. That's all this process of changing the thermal energy to the mechanical energy of the shaft. That's thermodynamics. That's something we will be learning in this class later on about power cycle. So that's all about thermodynamics overview, and hopefully you get excited about to realize there are so many aspects in our life is involved with thermodynamics. And all right, I'll see you next time. Bye.